Our problem is the following. Find the area of the largest rectangle that can be described in a right triangle with legs of lengths 3 centimeters and 4 centimeters if two sides of the rectangle lie along the legs. So there we have the two legs, which is 3 and 4 centimeters. Now we're gonna put the rectangle, which is gonna be in red. And you have the A, that stands for area. And we have there two sides, X and Y, in order to find the measure of the other sides that are not the sides of the rectangle. So there we've got 4 minus X, and 3 minus Y. There you have the equation, which is going to be of a square is base, pure base, so we have X, pure Y. We don't know the values, so we're gonna find the values. By using similar triangles. That side is 3 minus Y, the other side is X, and that side is 3 and 4. That's the side of the right triangle. Then, now we're gonna equal the triangles because we are using the similar to triangles. So we have 3 minus Y over X and 3 over 4. Then we are gonna isolate Y. By multiplying the sides. Now you see we've got Y, therefore Y, and it's gonna be 12 minus 3x over 4. But of course you gotta simplify it always. And to continue, we've got Y, but you use our equation that is X pure Y, and our Y was 3 minus 3x over 4. So we're gonna multiply that times X. After that, we're gonna get the first derivative. Now that we have the function, we're gonna get the first derivative. And you will know the rules to get derivatives, right? So it's gonna be minus 3/4 per 2x plus 3, which is minus 6/4 of x plus 3. That gives us minus 3/2 of x plus 3. After we have the first derivative, we're gonna equal it to 0. In order to isolate x. And now you see that we can use the lay of the tortilla. And that gives us 2. That point can be either our critical or not maximum or minimum point. Now that we got that x is equal to 2, we're gonna find out if it's our maximum or minimum point by using the ID test, which is increasing or decreasing test. Just for you to see, we're gonna put again the functions, so you don't get lost. We've got our value, that it's 2. We're gonna put a number that's greater and a number that's less than 2. And we're gonna, on our first derivative, we're gonna put x equals to 2, and we're gonna see if it's positive or negative, or 0. Now we're gonna use x in 1, and we get positive. What she did is that she used in our first derivative, which is minus 3/2 of x plus 3. In x she just put 1, and she got a positive answer, number. So it's so it goes up. It increases. And number 3, we're gonna do the same thing, but with 3. X is gonna be 3. And it's gonna be negative, so it's gonna decrease. And there you go. Do you remember that at the beginning of the video we found y? And y was minus 3/2 of x, fourths of x plus 3, and also we already got that x equal to 2. There you can see the x, so we're gonna substitute that x for 2, and we're gonna get the dimensions of y, since we know that the dimensions of x is 2. To get the answer, remember that you gotta simplify. So you get minus 3/2. Now you remember that we've got x equals to 2. So in our function, we're gonna substitute it by 2, sorry, the x, of course. You remember that that's our first derivative, because it's 2 to the square.
And our answer is 3.
Yeah, remember that we got that x equal to 2. We are gonna substitute it in our function, which was x per y, and we've got minus 3/2 per x squared plus 3x. We substitute x by 2, and the answer of our maximum area is 3.